Welcome, everybody. We are going to be working on Module 6 this evening. Tonight's topic is object-oriented programming, and arguably one of the more important topics in programming, because I think once you overcome this hurdle, a lot of mysteries of programming become unlocked, and your understanding deepens significantly to the operations of programming languages. The topics that we're going to look at are objects and classes, and that's where the primary amount of our focus will be. We'll get a actual understanding of what a constructor function is. We will learn that we can pass objects as arguments around a program, so we can move them around. We can also learn about this concept of overloading objects and constructors, and basically what that means is sending different amounts of arguments to a class and having it react differently as a result. And then we will look at this concept of what we call custom collection types that we create ourselves. And in many ways, really, objects that we create or classes that we create become custom data types in essence, or collection types. I think either term applies to this. All right, let's start talking about the concept here, and start breaking it down a little bit. So we're going to talk about a lot of general terminology here. So there's a lot of terminology and concepts as we kind of flow into this. First thing that we look at is, when we think about an object, when we're programming, as it says here, it's a software component that exists in memory, right? It's got two basic capabilities. One capability is to be able to store different types of data in what we call fields or data structures or variables or whatever. But in terms of an object or a class, we tend to call them fields. We also can get our objects to perform operations. And once those are inside of an object, we call them methods, but otherwise we know these as functions, right? So a method is basically a function that's inside of an object. We've been kind of using that all along, right? So when we do like console.writeLine, and we've talked about this, writeLine is a method in the console class. Right? That's really what it is. C#, it says, also gives us a structure called a property that can get and set data. So some of the data attached to an object we can change. Some we cannot. But when we do that, so when we get data from an object, we're retrieving it. When we set data for an object, well, we're sending it in, right? So get and set are really common words that we use. Often we call these getters and setters, right? You hear that terminology spoken a lot. And they pose a question: what examples of objects have we used so far? Well, I think I've already just mentioned the console writeLine. The writeLine method is a method inside the console object, and that's why it works. We don't know what the code is, we just utilize it. When we define objects, we will define the data fields, and then we will also define the methods that they have. We do this by the use of the class structure. When we build programs, like right now, we are building programs inside what we call the program class, right? And then we have like a main method inside that class that actually executes our code. And thus far, we've kind of been obscuring it from ourselves. But as we start to work at this level, we're going to stop doing that, because if we're going to create classes that are inside the same file, we need to see the whole hierarchy. And we'll talk about the different approaches for doing that. But basically, think of a class basically describes an object, right? And you can also think of it once again as a custom data type, something that you are creating with all the features you need it to have, what information it holds, and what actions it can take, depending on your needs and what you're creating, right? In some cases, we can use generic classes to do things, but sometimes we have to create our own because it just makes sense to do that because it doesn't already exist. we like to think of the fact that classes do define objects, right? And it gives a little example here. It says, until now, we've been using a class file as a container for statements and local functions, but they are a lot more, right? So they're giving you some sample code here, like you have a couple of variables, and then you have a function that's defined down here. We don't see the rest of the function, but we can run that function, get a value, and store it here. And so far, all the stuff we've been creating has basically been sitting inside the main method of a program class. We just stick all our code in there and it runs, and we don't kind of care about it, right? That's been our pattern. Well, we're about to change that. So we're gonna, go a little bit deeper now. There's kind of an interesting thing. Like when I'm like using like a traditional variable, we think of this as a value type. So for example, I set up this variable to hold a number. I tell it what kind of data it's going to hold. I can assign it a value. And that's a pretty simplistic process. Really, what we're doing is we're creating a memory storage location with a name, and then we put stuff in it. The kind of storage location it is kind of dictated by its data type. When we create an object, that takes a little bit more work. And normally what we do is we see this new keyword prefacing a function named the same as the class name that we're trying to create, right? So whenever we want to create, in this case, a new random or new randomizer, basically, we call upon the constructor function or method inside the random class to create a new version of the class based upon the blueprint defined in the class. And so I think of this very much like when we build a house, and you see this, like you drive into a subdivision, you go, wow, most of these houses look exactly the same, right? Because they basically all use the same blueprint. And all they really did is maybe put different siding on, a different roof, or maybe on one house the garage is attached, on the other one it's not, but it's basically the same floor plan. They're following the same blueprint, but yet all the objects or all the houses that we create from the blueprint are unique and have their own name and identity and have their own features that make them unique. All right, so kind of going down this rabbit hole a little farther, value type variables versus objects, right? So we think of like a traditional variable, and it says value type variables really can't do anything. They just hold information. So when we declare those, the compiler sets aside enough memory for the variable's value. So if I declare an integer, and I don't know if you guys recall this from early on, but like certain data types have certain capacities. Like if I declare an integer, that's different than a long or a byte. You know what I mean? They have different capacities, so they occupy different amounts of memory, right? And in a double, because it's a floating point, might occupy a different amount of memory than an integer, which is not, right? And it's all about how memory is allocated. When we create objects, from the blueprint of a class, the object itself does get stored in memory. So like a variable, it'll sit there in memory. And we have a name for it, and we think of that as the reference variable that basically tells us where it's located, like the address of the house. Like, where is the purple house? It's at 123 Elm Street, And so the reference variable, the name that we give it, identifies its location in memory. And then, and I like this is a good analogy. It says like the string attached to a kite, we use the reference variable to interact with the object, right? And so that name that we give it allows us to interact with that particular instance of the object. And if you want to like use the house analogy, like knowing the address of the house allows us to interact with that individual house, by name. When we declare an object, we will see this syntax, right? And it says, we declare it as a reference variable. So we're still kind of basically setting up a variable. We're declaring its data type, which is the class name that we've developed. Now think about this. When we created, arrays or lists, and we use that new keyword, right? This is very much like that, where we're using this constructor function here to build it. This will create the object in memory. It gives it a memory address, and it gives it a name, right? So this creates it. This tells us what data type it is, the class that we're hoping to build. And then this gives it its unique name, which makes it different from all the other ones that we might make from the same class. Now, I think this is kind of interesting. And it says the C# API, like all the standard libraries inside of C#, have a bunch of different classes you can access right out of the box, right? Like, for example, when we do console write line, that's built in. Or if we're using a particular data structure of some sort, that's built in, right? But when we're making stuff for ourselves, we do want to make things that maybe don't exist. And they're going to use this example here of a rectangle class, right? And I want you to think about like what makes a rectangle, right? Well, first of all, in this scenario, we will give the rectangle a name. The name will make it unique, right? And then basically a rectangle is defined by its two dimensions, its length and its width. We know that all the corners of a rectangle are 90-degree angles, right? So they're perfectly square in the corners. So it's really two pieces of information that define a rectangle, length and width. And then if I'm going to create a whole bunch of rectangles, I should give it a name so I can recognize, well, this is rectangle 1, and that's rectangle 2, and that's rectangle 3, all of which might have different lengths and widths, or might have identical lengths and widths. It doesn't really matter. When we create the rectangle class, we will give them those 3 data fields, name, length, and width. And then we would like the ability to change the name, to change the length, and to change the width. Or if we want to retrieve that information from the object, we can also do that. And then by virtue of having those 2 pieces of information, it's very easy to get the rectangle's area, because that's just a simple calculation based on the 2 numeric values that we have stored, right? It's just an extrapolation of that data. Just multiply them together and you have the area, right? So we have the ability then to have the 3 data fields, to set the values for those data fields, to get the values for those data fields, and then to do a custom action related to those, right? So once again, just to kind of ramp up the terminology here, fields or data fields, right, store the values. In this case, it'll be name, length, and width. Then we will have functions, or when they're part of a class, we call them methods, right, that provide behaviors. Some of the behaviors might be updating the name, length, or width, or retrieving the name of the length, width, or name, or whatever, or calculating the area. Those are all behaviors that we can dictate through methods. But notice that the storage of the information and then the changing and retrieving of the information are really 2 different tasks, right? One is the storage of information. The other one is actually a thing that we do. All the stuff that we put inside of a class, syntax wise, we call those class members. The data fields are class members and the methods are class members. They're members of the class, right? When we start writing the code for a class, we use this syntax, right? We say public, we say the word class, and then we say the word rectangle. The word public can also be set to private or a couple of other things, but usually it's public or private. It's not absolutely obligatory that you use private or public, but if you don't write it down, public is assumed, by the way, right? So it's usually better to declare it. Public technically means that we can use the class anywhere in our program. So all of the data inside of it and all of the methods inside of it are publicly accessible from outside the class. And that's how we're going to use our classes, right? All the class members go inside the curly brackets that you see there. And then properties will likely be used most often. And those are the data fields at the top, basically. And then we'll explore all the different types of class members, as it says. Right? So we would start to do something like this. And I feel compelled already to go into like a demo on it. So let me go ahead and get Visual Studio going here. Code along if you wish. Let's go ahead and close our solution from that assignment. I'll create a new project. Don't hastily proceed here because this time we are going to do some modification here to this checkbox, right? Where normally we leave this unchecked. I do want to check it this time. I want to see the top level statements, right? Because we want to see the class structure. We want to see the namespace because we are going to create our own class structure inside the class structure. All right. So not to sound convoluted about it, but that's what we're doing. And so here, once again, is the typical structure of a real C# program when you don't obscure the top level statements. The top level statements being all of these. What we've been doing is dropping all our code inside here, obscuring these curly brackets and these up here, and we just flow with it and whatever it works, right? But now I want you to notice that, all the program stuff that we've been doing has been sitting inside the main method, which is part of the class file called program. And I want you to notice that our file is called program.cs and the program class is called program also. That is not a mistake. Those must match. So we call it program.cs because the class is called program. Now, what I will say is when you do create a class file, you have two options, and we'll see this in a moment in the slideshow, that you can create the class file internal here with your program. So I'm going to basically come down here at this level and I'm going to create a new class here, right? Or I can create it as a separate file, and as long as it's in the same structure, it will see it automatically. So either approach is okay, and I'm just telling you that up front. Generally, for the stuff that I'm going to do in the class, I'm going to probably put the class files in with the program file just so that we can see it on one screen. But you don't have to do it that way. In fact, you should experiment with it both ways, is my recommendation. All right. Since we're going to be creating it there, they're already kind of giving us some of what we're going to do. So they want us to create a public class called rectangle. I want you to notice the capital R here. That's a convention. And in fact, I mean, really, you could just copy this code verbatim. So I'm going to do that. I'm just going to copy that in and drop it in. All right. So I want you to notice, and I want you to be certain about this, that this class sits at the same level as this class in the structure. They're in the same hierarchy level. They're inside the same namespace. The namespace corresponds to the solution name here, right? So we're inside that same namespace. The other thing that you should know as we kind of start digging into this is in the program class, we put the main method in, and I want you to notice this. This is a very typical, expression here. I'll zoom in just a little bit so you can see it. But static void main string square brackets. What does that imply? An array structure, right? Args, like a pirate, args. And here's the thing: like when I first learned like these statements, I think I first learned them. Oh gosh, was it in C++? Probably, and then in Java. And we didn't have tools that would auto-generate the code for us. And so I'd have to go in there and in Java, what you always say is public static void main string args, and you'd have to memorize that, right, to type it in. But what I will tell you about the main method is if you put code here, when you hit this run button, it is this that executes. If I take my programming code and put it here, or come up with another function or method name and put it there, and I hit the run button, nothing happens. So this is why, like when we start teaching you programming in C#, we omit these top level statements because it's really easy to put the code in the wrong place and then not have anything happen. So the main method, if your code or something, isn't inside here, nothing will happen in your program, period. Right. So very important. Now, the class that we're creating here will be devoid of a main method. It will not have executable code in the way that we're thinking about it. It won't execute its code unless we call upon the class to execute. And we won't call from it. Remember, the class file will become a blueprint. Right now, what all we've defined in that class structure is the fact that anything outside this class can access it, right? That would mean inside this program and anywhere inside this namespace. And we gave it a name, right? So we can refer to it by name, and we've declared 3 data fields. And I want you to, we'll talk about what all of these settings mean, but basically we have 3 data fields or properties, if you will. One is the name of the rectangle, the length and the width. And then notice that the length and the width have little get set features next to them, which allow the values to be changed externally, basically. Looks like Sam got bumped out and now is coming back in. Let's see if he jumps back in here. All right. So as we kind of proceed here, I'm hoping that you guys are following along in the same fashion. So I think that helps. Right. And they do make a point here, right? The data fields, when you build a class structure, we usually list all that data at the top of the class. That's the convention. They do not go inside of a method. Methods sit separately, right? And they make the point here that fields aren't inside methods. They belong to the class. So it's kind of like global variables for the class structure, information that's particular to that thing that you're going to create and that object that you create from it. They make the point here that the variable name is a private field. Did you guys notice that one was set to private? And the variables length and width are public properties. So that means they are accessible external to the object. So there's a reason for this, by the way, because think about it. If I create an object, right, I don't necessarily want to change its identity, but I might want to change its size. Like if I was creating a house and I gave it a location or a name, like an address, right? That address is very unlikely that we'll put that house on a truck and move it down the street. You know what I mean? Not that it's not possible, it's possible, but it's going to stay in one spot. So that we're going to just leave alone. But the length and the width might change. I might expand the size of the house. I might, change the siding. I might change, whatever. You could change features of it afterwards. But some are set to private, some are set to public. Notice that the data fields do have data types, and we use the same conventions that we use in regular, C# programs. You choose your data type, you give it a name, and then in some cases add extra stuff to it, right? And we'll get to all of that one step at a time. There's a kind of a neat analogy here, just kind of, riffing off the whole house thing. And, it says here, imagine the flooring plan or the floor plan of a house, right? And here's a house and it's got, a few bedrooms, dining, kitchen, living, patio, a bath. And this is pretty true in most houses. Rooms tend to be rectangular because those are easy shapes to build. Sometimes you get rooms with curves or little jut outs or L shapes or whatever. But for the most part, rooms are, rectangular, square, and they have certain sizes. Really a good analogy for the rectangle, right? Because each room's got a name, each room's got a size. Every room is a unique entity, but they all share those features, right? They all have a name, they all have a length and a width, right? So they're the same type of object, if you will. They use the example here, the rectangle object for the kitchen has its own length and width, and it's a different place in memory than the bedroom rectangle. And notice we have 3 generic bedrooms, and 2 of them are the same size, but they're clearly not the same bedrooms. So really, we should probably call one like a master bedroom, kids bedroom 2, or something like that. But they are unique. even if we're just generically calling a bedroom and they're the same size. This one's 13 by 12, but it's certainly a different bedroom than this 13 by 12, right? So you can share some features, but they're still unique, and this is where it's kind of weird. And it says one way to think of an object that is as a collection of related values, and the values are kept together as in memory, right? And so if I develop a kitchen rectangle object and it's stored in a certain spot, it does carry with it those values, length, width, and name, right? So when I construct a kitchen object, right, I might do this. So if I create a rectangle class, I can then create a kitchen object by calling for a new rectangle. And when it's created, right, because I'm not feeding any data in here, it's going to create length and width, which will default to 0, and name will default to null. Those will be the default values that are created, right? And just to show you that even with the primitive level of the program we have here, I could come in here and just say rectangle. And notice how it picks up the name in the IntelliSense. And I can call it, I don't know, kitchen. And I can say new rectangle. And I'm just going to close the parentheses. And it doesn't yell at me at all because this is a valid type of class. And what this would do is it would create a kitchen object. And all of these data fields would be empty. 0, 0, and null for name, because those are the defaults. But it did create the spot. So it's kind of like, okay, I'm going to create a new kitchen object, right? So I framed it, but there's nothing in there yet, and I don't know what size it is, but it's going to be there. I just set the parameters for it. All right, moving on. All right, so just to kind of hammer the points home, right? When we create the rectangle class, we can't run it, right? It doesn't have a main method, so it's not runnable code. And the blueprint analogy is a great one. It's a blueprint to create rectangle objects. It's the pattern that we will use to create all other rectangles, right? We're going to use it in the main method, right? And we're just talking about this, right? But the main method really sits inside the program class. And this one we refer to as the driver class. This is the one that's capable of running the main method and making the program execute. So that's why we call it the driver class. Notice only one per project. So I can't have like 20 main methods, in my project. All right. So what they're going to have us do now, and we're going to kind of play with this a little bit, is we're going to create a program called Flooring Calculator, right? We'll create the rectangle class as we've got it so far. And I'm just going to work in the file that I have. And if you want, and it's making the point here, you can create the class as a separate file. So I could go into Visual Studio and I could right click here and I could add a new item. And notice one of the options is class. And I'm just going to do it just to show you. And we're just going to create a generic C# class. And I'm going to call it, I don't know, rectangle 2, right? Because I don't want to like mess up the one that I have. And then I'll add it and it'll just add a program file here. So the work that I'm doing here as a class file could actually just be placed here instead. And then when I call upon this file, it will read that file automatically. I'm opting to put this all in the same file just so I can see it all at once and like scroll and see it rather than flip screens. But once this is defined, there is nothing wrong with it being in a separate file. This will still utilize it much the same way. And for example, I can call upon rectangle 2. See how the IntelliSense pulls it up automatically because it's in the same folder. So this is an option for proceeding as well. I'm not going to use that approach right now. Later on, I'll experiment with it just to show you guys. But I just want you to be keenly aware of that because I think that's a important aspect. All right. So, um, all right. In our program CS file, create a rectangle object, right? And let's call it kitchen. Well, I kind of already did that, didn't I? Right. Um, and then start thinking about it. Every room can have its own name, its own length and width, and you can create as many as you want. So if like you think about all the rooms in your house, you can start like listing them and creating them. So if you want to, have a little fun with it just to practice doing it, so I can do like dining room, right? And that's a new rectangle. And then I can do another rectangle. And this one could be, I don't know, bathroom, etc. And heck, let's just do a bedroom while we're at it too, right? And the point is, it's like once the class is defined, you notice how it like totally auto types, the stuff for you because it recognizes it as a valid object type. So it just incorporated into the IntelliSense library or whatever it is right away. Now, for those of you that might be using Visual Studio Code or maybe even Writer or something, I don't know how automatically the IntelliSense on those picks up the new objects, but here um, in Visual Studio, it's like instantaneous. It's a very, very high quality IntelliSense in Visual Studio. All right, let's keep moving forward here. You can keep creating as much stuff as you want. All right, some more terminology because the terminology is important, and this is transferable terminology, by the way. The class declaration is the blueprint. The object is the actualization of the blueprint. So, like with a house, I have a blueprint, and then I have the house. The house is an instance of the blueprint class, so to speak, right? And so this is one of those keywords, right? So when we create that kitchen object, that's just one version of the rectangle class. And when I create a bedroom object, that's another instance of the rectangle class. And then the process of creating the object is called instantiation, right? And I remember really struggling with that word when I first learned how to program. So an instance is one instance of a class, but it's an actual instance. And then the process of creating is instantiation. And as they indicate here we instantiate two rectangle objects. As we create them, we probably want to put values in there. We probably want to name them. We probably want to give them lengths and widths. And then the question, of course, then becomes, well, how do we do that? How do I actually put the values in? And that's done a couple of different ways, right? There's a few different ways to make that happen. And then every one of these, of course, right, will get their own data values, and those, fields or data fields are called instance fields. They're tied to that object directly, and they travel with the object. So whatever I set them to be, they're going to follow that object around and never leave it. So this can be a couple values, or it could be dozens or hundreds of values, right? It can be very complicated objects when it comes down to it. So this is really actually pretty simple to do. This is kind of interesting. It says to access an object's fields or method, use the variable name plus a dot plus the member name, right? So in the program that we're building, and it's asking, can you set the length and the width? And how about the name? All right. So there's a few different ways to do this. And what I like to demonstrate here is both of the approaches are actually all the different approaches that we'll actually kind of get to using here. But this is one approach, and this is actually kind of a neat and simple approach. So I've named the object, and then I'm accessing its name property. Notice no parentheses because it's a property. It's a variable that we're setting basically. And then we're going to set it to this string. So if you want, you could just copy this, right? And we can take it right to our program here. And where will we set this? Not inside the class file. We would set it inside the program body. So I would do something like this. And I want you to notice it's underlining red. Why is it underlining red? Well, let's hover and find out. Say, rectangle name is inaccessible due to its protection level. What protection level are we talking about? Well, it's set to private. That means the code outside this class definition, right, or the object, and really, truly, this is the blueprint, but this kitchen that we created has all these features, but that's set to private and I can't change it. Now, notice what happens if I change this to public. All of a sudden, the problem goes away, right? Because now it's accessible outside the program, right? So, and what I will put here, right? I'll say originally set to private. And in many circumstances, there are fields you want to leave as private because you might set the name right when you're creating it, and then you never want to change it again, right? And I'll use the analogy of the house again. If I put this house at this address, it's very unlikely we're going to pick that house up, put it on a truck, and move it. So that address is going to stick. Right. I just put it in there, but this would do it, right? This is one way to feed the information in. And therefore, and what they're really saying is, can you set the length and the width? How about the name? And really, they want you to fail with this step, and I'm showing you why it's failing. So I am going to switch this back to private, and we'll do this, and I'll say won't work because it's private. Duh. No, we'll leave the dot off of there, right? But that's why. But if I want to set, for example, if I want to do kitchen dot width, I set it to 10. Okay, that works. Or if I want to do kitchen dot length, and I want to set that to, I don't know, that's kind of a small room. Let's make it a little bigger, right? I can set it to whatever I want. And then those will actually get attached to the data fields inside the kitchen object. Dining room has its own, bathroom has its own, master bedroom has its own. But using the dot syntax, we can access and set those properties. Why? Because A, they're set to public, and they have getters and setters attached to them. This is technically a set, in terms of process, right? All right. All right, so let's talk about the field access thing. It says properties are commonly declared as public, they're available outside of the class. A property stores data in a private field which cannot be accessed directly, and sometimes we do that for various reasons. The set method is called with an equal sign, and the get method is called when the property is referenced by name. So, for example, if I want to retrieve the information, I just call on the property directly, and that will work. So I can use that statement. In fact, let's try it, right? And then I'm noticing, okay, these are doubles, so really I should be doing this, right? It doesn't care, of course, that would cast either way. But if I want to console right line kitchen dot length, it will do it. And in fact, at this point, I could actually run the program, right? And you'll see that it will throw the length on the screen. Very exciting, right? But proof that we created the object, set a property, retrieve the property, and put it back up on the screen. All right, moving on. This is kind of interesting. It says by default, the fields are private, meaning that they're hidden, right? And notice what it says. It's recommended to explicitly say they are private. So if I exclude the private declaration on it, they're private. That's the default, not public. Private is the default, right? Do you really want people looking at your data? You know, or do you really want people knowing the measurements of your rooms? I really don't know. But if you want them to be accessible, right, you know, public is the keyword. But then it asks the question, and it says, but how can we access them if they are hidden, right? And then we talk about uh, what we call public methods, right? So in other words, it says in object-oriented programming, classes hide their data, control access by creating public methods or properties. And so here's one of the aspects of this, right? And they're kind of making a silly point. Like, what if you allow your user to go in there and there's nothing that says that I can't put in a negative number for a length or a width, which conceptually makes no sense. I can't, you know, I can't go into an alternate universe and go into a dimension that doesn't exist and have it negatively sized. Maybe in a different universe, perhaps, but not this one, right? So just the fact that that value doesn't make sense, we can control that is part of it, right? So, but one of the dangers that you run when you have stuff that's accessible outside the class structure is the fact that you can feed it wrong stuff, right? All right, we are reaching kind of a topic split point here. Let's take a 5-minute break again, and we'll come back and continue. So I'm going to pause the video. All right, let's keep moving forward here because we still have to you know, worry about, you know, this public-private thing, and also like putting in values that don't make sense, you know, that kind of thing. And there is a way that we can actually force the name to change, and it's by basically creating a method. And so we're going to follow this approach here. And I want you to notice how this is kind of clever, right? The name is actually set to private, so we can't directly access it as a property, put in an equal sign, and just assign a value. It just won't be allowed because of that private designation. But we could write a method called setName, which accepts the string as a variable, and then we feed it in and set it to name, which then would go into the object because this would be public, accessible from the outside. And because it's inside the class or inside the object, it does have access to the variable name. So see the kind of the clever approach to this. And you know, when we build something like this, it really has to do with the fact that we're in scope with the object. I mean, right? So we learned about kind of like global scope and local scope and how a variable really only exists inside a set of curly brackets or inside the, you know, the or parent object, if you will. The modifiers that we use here are kind of the same ones that we sort of use for doing functions, right? So the first one is the access modifier, right? Public, private, which we're kind of figuring out what that does already. And then there's a return type. So does this method that we're going to build return information? No, it's just setting a variable. It's not returning anything anywhere. We give it a name, we put in a set of parentheses, and then if we're feeding data into it, we declare the data type and give the variable an internal name for the method, right? Pretty typical stuff, you know? And then we ask these weird questions, right? Like, so when we did this, why did we set this to be n and not something else, right? Couldn't we call it name? You know what I mean? Because that's what we're setting. And so this, it really actually kind of creates sort of like a little bit of a problem. And that's really what the next few slides are about. And I want you to think about this, right? Like if any of you guys have done Python, Python kind of allows for this thing that we're about to demonstrate here, which was really a bad idea, by the way, because in C# it doesn't work, basically. And so basically, this really kind of deals with, it's a scope issue partially, but it's also kind of the mechanics of the language. Right, so we've talked about scope before, so I'm not going to hammer this too much, but it's like the scope basically refers to where a variable is accessible and changeable or available to either, you know, a piece of code or not. It says here that instance fields, meaning the data fields inside of an object are all available to all the methods inside that object. Makes sense. Why? Because they're in the same set of curly brackets. They're in the same parent container. Public instance fields can be accessed by code outside the class. Private cannot. Methods are the same way. If you make them public or private, those are internal to the class structure. Now, this concept of using the same name basically twice is called shadowing. And once again, I mentioned like in Python, you can make it work and Python doesn't care. You know, I don't get why it works in Python. It's just the engineering of the language. And it says you can't have two local variables with the same name in the same scope, and this includes parameters. And this is really what we're trying to do. It says you can have a local variable or parameter with the same name as a field, right? But the local variable shadows the field, and the field is hidden by the local variable. Okay, that's very confusing terminology, but this is kind of what we're talking about. So, like, and I want you to think about this. In Python, we could do this, right? But in C#, we basically can't. But this is the thinking. Like, why do I use the letter N? Why can't I just say name? And really, like, if I'm feeding in name here from the outside to change the name of this, you know, that'll travel here, go here, and then this will get assigned to that, and then we're okay, right? Because, you know, they're all named the same thing after all, right? And here's the reality, though. This is really what happens because this name is local to this set of curly brackets. Really, what we're saying is name equals this name. These are the same. This one wouldn't be affected. So that's why it doesn't work here. And so there's a couple of workarounds. Here's one workaround. You can use the this modifier, meaning that this name, these two are unique to this method. When I use the keyword this, and I think you'll see it on the next slide, that's a keyword that says which name? The one that belongs to this object that we're currently looking at, the higher level object. So that is an approach. And any of you that have ever coded in like Java, for example, this is not a new thing, or JavaScript even uses this approach. And oops, I jumped a bunch of slides there. And basically it says that this keyword references the current instance of a class that the method is running, right? The parent structure. And it says we have one instance so far that we can access with our kitchen reference variable. Now we can clean up our set name method and try to use it, right? And we could actually go through that whole process of creating the set name method using that approach, right? So for example, I could write basically this code and this would work, right? I'm not sure really still that it's necessarily the best approach, right? Just because we can do it doesn't mean it's the right way or the best way to do it. And what, you know, I'm basically going to do kind of like a little pattern here of talking about how we get there and then why the one approach is better than the other. But what they're really referring to here, right? And I suppose I can copy the code right from the slide because I'm using the same stuff, right? So I could just come in here, copy this, and then come down here and inside the class structure, I'm going to just do this. Now notice it doesn't throw any errors. But if I do this, okay, notice it's not exactly an error, but it's saying it might end up being null here because the assignment made to the same variable. Did you mean to assign something else? You know, and so it doesn't like it basically. And so I'm going to control Z my way out of that. But I am going to just up here, just very quickly do this. I'm going to run the set name method, and I'm just going to say set name. Oh, wait, yeah, right. I got the kitchen prefix that, you know, how quickly we forget. And notice how that comes up as a method from the class. And then it's expecting a parameter, which is a string. So I'm going to give it the name kitchen because that's what it is, right? And then to prove that it worked, we can console right line the name, right? And the name is all lowercase. Notice what it's doing there. Okay. It's treating that as what? Well, it's still inaccessible, right? So we still have this problem. Now we also can't read it. So we also have to be able to return the name. And this is, we're going to learn this here in just a moment. So I'm kind of jumping the shark here a little bit. And I'm going to put in a get name method as well. That doesn't need anything coming into it. But what it will do, inside the curly brackets here, and notice what it's suggesting is the same syntax, right? Which name is it returning? The one attached to this object is the way you should think about it. Right? So we have a set name and a get name that we're hand coding. Why? Because this is inaccessible this way. So instead of saying kitchen.name, I would do get name and parentheses because it is a method. Right now, extract the information from the object and put it on the screen. So here comes the run. Right. Yep, we put it in there and we pulled it back out, but it shows that it works, right? So that's one approach for working around that issue, right? We're going to try a couple different ones though, because just because we have this one approach doesn't mean it's necessarily the best approach. And once again, we call this shadowing, and we can go ahead and set the name, right? Let's put the information in there. And then we have maybe a better approach. And this is one that I usually push my students to use. We do this in other languages too, but sometimes when we're feeding in a name like this, there's some people that use this convention basically that all the instance variables maybe are better off being named with an underscore in front of them. Right? And think about this, because that way I can identify by looking at my code that this is an instance variable or instance data field that's internal to this object. And it makes it really easy to spot the difference. So you could use this approach too. And so just to kind of demonstrate it, I can just come up here, put in my underscore. I can get rid of the this, right? I can use an underscore there, and I can use an underscore here, and I'm back in business. That's an approach to use too. And really, the approach that they originally showed, which was just name and then the small letter N here, that's fine too. Any of the approaches that work are okay. And I just want to reinforce that fact. Any approach that you use is okay if it works. There are certain conventions though, and this once again is a convention that a lot of programmers in the C# space do use, right? So instance data fields will often have underscores as a prefix just so that you can quickly identify them, right? All right. So terminology once again. So kitchen is a reference variable, right? Because we created it as a new rectangle object. Its data type is rectangle. It holds the memory address of a rectangle object, right? That variable name. And then we can set the properties. We can create an object. We can set the properties. And because kitchen is a private field, we can do that with the set name method that's built into the object. It's part of the object. Right. We're still running into this problem though, right? Because I could, in principle, give a length that doesn't make sense. And think about what a problem that can cause. I want to calculate like how much materials or how much flooring I need to buy. The negative number would really screw that up, right? So do we have a way that we can handle that information? And there is a way, and this is one of the ways that we're seeing right here. One of the beautiful things about, being able to build a class and have data fields inside of it is other people that might be accessing the class to use it don't necessarily need to know how it's built or what the mechanics are inside of it that make it work. And we call that data hiding, right? Or the black box, it's like you don't get to look inside, but this is how it works, right? And it says it puts the programmer in control of the rules and logic for how a field is modified, right? So it says a property stores data in a private field which is named value, right? You can use a combination of private fields and public properties if you want to include input validation. Otherwise, the shortened get set is preferred. So like if you're okay with whatever values get thrown in, you can just put this right after the name of your length and no problem, it'll work, right? That's fine. But you're taking the risk of whatever the user puts in could be right or wrong. Now, here's a devil's advocate here. I could write code in the main program body to prevent the wrong values coming in. That would be a good practice. I could write code that said, hey, if the number is less than 0, ask the user to enter it again, right? Or I can put that into the object itself so it travels with the object, and then my program code up above is simpler, right? I don't have to build it into the program code. So what we would do here, and I'm going to just copy my code here from the other screen so I don't have to retype it, is we will replace this with these statements. So we'll make a private field called length with the underscore in front of it. And then we're going to make a method, right? This is a method now, right? It's a public method that we can access from outside. So when somebody calls the length, what they think is the length property, and I want you to notice no parentheses here. So this is treated as a property where this is a function that needs the parentheses. And we put inside there, just like we did before, get. And what does get do? It just simply returns the length that we have up here. Then we set up a set, curly brackets, and then the set will do the check. The value that we're trying to apply to it, right, with an equal sign basically, will only apply the value if the length is greater than 0. If it's not, then it's just not going to work. The data structure inside the class object will prevent it from working. So now, do I need to change my code here to make this work? No, this will still work. But what it'll prevent, right, is if I take this, right, and I change it to a negative number and then try to right line the length. I don't know if it'll even get to the point of right lining the length. But let's run this and see what happens. Any predictions on what the output will be? I don't know. Let's find out. Let's run it. All right. So what happened ultimately, if you look at this, we set the length to 15. We put it on the screen. That's this. Set the name to kitchen. We put it on the screen. Then we tried to set this to -15. It just didn't work. No error messages, no warnings. It didn't crash the program. The data just didn't go in. It kept it at 15. Now, maybe using the same number twice is not a good idea. So if I did it like this and ran it again, you'll notice it's not changing to 22. It stays 15. That's a better example. Right? Using the same number is probably not wise. All right. So that's kind of the demo on that. So this is kind of a way like you can structure your objects to not break. Right? Pretty commonsensical, really, when you start to think about it. All right, I'm trying to see how, like, where's a logical stopping point here, and I think we might be, you know what? Let's do this one last slide, and then I think we'll call it a night, folks. All right. When the rectangle object was first created, instantiated, it said what values did name, length, and width have, and we know that the numeric fields were zeros, and the string field was set to null because those are the defaults when we don't put anything in. They do make the point here that it's an error to omit the parentheses when creating an object. So I'm noticing there's one more try it out. Maybe we do the try it out. And then, well, you know what? Let's start the next session with this. So this is where we're going to cap it. We're ending at slide 43. And then when we get back together on Tuesday, we'll pick up on slide 44 and then work our way through the rest of the presentation. And then we'll work on the lab and the assignment. All right, folks, this video ends here and class is